Hello class, and thank you for watching. In this lesson, you'll compare the rates of change of 2 points using average rates of change near the points. You will describe how two quantities vary together and different intervals of the function. So what we're going to go over in this video is how to calculate the average rate of change for nonlinear functions. The average rate of change, so let's begin with the vocabulary. The average rate of change between any 2 points on the graph of f of x is the slope, the slope through those 2 points. The formula that we use for such an occasion is the same formula you used in Algebra 1. That's y2 minus y1 over x2 minus x1. In today's lesson, I'm going to substitute the values of y2 and y1 with f of x2 and f of x1. F of x2 correlates to my y2 value, and f of x1 correlates to my y1 value. And then, of course, x2 minus x1 in the denominator. So what we're doing is figuring out on average how fast nonlinear functions that are not straight lines, obviously do not have a constant rate of change. They're changing at different intervals and at different speeds. Like if I look at this slope right here, that's going to be different from -4 to 0. That is, if I was looking at -2 to 0, that would be a different line, and that would have a different slope. The slope would be going downwards. So we're going to look at how do we calculate on average how fast, yes, because slope rate of change, how fast the graph is changing in different intervals. So let's look at the first example. Now, the first thing I'm going to go over, first of all, is that intervals we're going to be looking at are going to be closed intervals, and we're going to be using this notation, x1 and x2. And if I have multiple intervals, that will be just being x2, x3, and x4. It doesn't change, again, the formula overall. The procedure is still going to be the same. So in this example right here, in the first one that we have right here in example 1, the graph of g of x is shown below. Let's find the average rate of change of g over the interval of 0, 1, and then 2, 3. So we're going to first look at how is this graph changing between the x value of 0 and the x value of 1. Okay, so if I plot those at 0, we have a point right there, okay? So this is 0, 1, the coordinate 0, 1, not to be confused with the interval 1, 0. This and this are not the same thing. This right here is referring that we're going from the first x of 0 to the second x of 1. At 0, the y coordinate, again, remember on how we evaluate functions, our y coordinate is at 1. So we have the point 0, 1. So that means that when f is equal to 0, our y value is equal to 1. And what we're going to do now is look at what is the y value when x is equal to 0. So when x is equal to 1, I'm going to do this one in blue also. We have that point right there at 0. So when x is equal to 1, the y value is equal to 0. So these are my y1s and my y2. My x1 is 0 and my x2 is 1. That again comes from the beginning. That comes from this interval right here. My x1 and my x2. What we don't know is what the y values are, so we have to determine what the y values are at those corresponding plots, which we see again are at 0, 1 and 1, 0. So now what we're going to do is that we're going to now look at the average rate of change. We're going to look at how fast that if I draw a line from this point to this point, what would be the slope of this line right here that I have in blue. So using the slope formula, y2 minus y1 over x2 minus x1, we're going to plug in those corresponding values. So my y2 is the number 0 minus my y1, which is the number 1, and I'm going to divide it by x2, which is 1, minus my x1, which is 0. So -1 over +1, that equals to -1. So that is my average rate of change, which I'm going to abbreviate as ARC. So the average rate of change in the interval from 0 to 1 is -1. which correlates again to the slope of this line essentially, and which makes sense because this line is going downwards. That is what the slope of the line is. It is equal to -1. Now let's look at what the rate of change is from the points. And I'm going to call this again x1 and x2, but I'm going to do it in red this time. So this is going to be my x1, and this would be my x2 from 2 to 3. So at 2, the y value is 0. And make this smaller because I made it a little bit too big. Okay, there we go. So when x is equal to 2, the y value here is 0. So this is going to be my y1 value. And now I'm going to plug in the 3 and look at what is the y value when my x is equal to 3. So I'm going to evaluate f of 3. And that point was up there. This point right there in red. Well, this point again has a coordinate of 4. If you look over here. So when x is equal to 3, the y value is equal to 4. So this is going to be my y2 value. So my x1 is the number 2, my x2 is the number 3, and my y1 and y2 again are 0 and 4 respectively. So the way we're going to figure out the again the arc, the average rate of change, is by now getting the slope formula. So y2 minus y1 over x2 minus x1. So the y2 is 4 minus 0. And again, I forgot to do this. What I'm doing now is I'm looking for the slope of the line that connects these 2 points. So if I draw a straight line from the point down here at the x-axis to the point right there at 4, 3, we're looking for the rate of change. So we're looking for the slope of that line that would connect those 2 points with a straight line. So that's why we use the slope formula. y2 minus y1 is 0, 4 minus 0, I'm sorry, and x2 minus x1 is 3 minus 2. So we end up with 4 on the top, 1 on the bottom, which equals to positive 4. So the average rate of change our average rate of change on the interval from 2 to 3, from x2 to the point x3, is positive 4. Which makes again sense, because if we look at the line, notice that this line has a positive slope since the line is in fact going up. So that correlates again to having a positive slope. But this line right here that's going down, that should have a negative slope, and it does. It has a slope of -1. So that's how you figure out the average rate of change. Let's look at some more examples. Let's say we're given a function and we want to figure out the average rate of change of this function. Well, again, I need to use the same formula. The formula we're going to use is y2 minus y1 over x2 minus x1. And I'm given on the interval of -2 to -1. So I know that this is going to be my x1, and this right here is going to be my x2. What I don't know is what's the y2 and the y1. So what we're going to do is, in order to figure out the y1 value, is that we're going to substitute in and plug in for x the x1 value of -2. So for our function f, we're going to figure out what f of -2 is, because remember, y equals to f of x. And to figure out the y coordinate, we're simply going to replace x with these values here and figure out the corresponding y coordinate. So to find the y1 value, I plug in the x1 value into my function. So this would be negative, and the x is -2 to the third power plus 3 times -2. In order to do this by hand, I first have to work with exponents. So -2 needs to be raised to the third power, which means -2 times -2 times -2. I'll do that work over here on the side. That equals the total of -8. So minus -8. Multiplying 3 and -2, that's equal to -6. And negative, that's equal to a positive value. So, and a positive times a negative right here, that's equal to negative. So we're going to end up with a total of +2. So my y1 value, which is f of -2, is equal to the number 2. Now I have to figure out what the y2 value is. And the way we're going to figure out the y2 value is now to evaluate f at the x2 value, which is -1. So I'm now going to substitute in the x with -1. And again, I do the same thing. And so you see I'm replacing these x's with these two numbers to find the corresponding y values, the y1 and the y2. Now I'm on y2. So -1 to the third power, that's going to be -1. And again, I have two negative signs because of this. I'm bringing this negative sign down. I don't know if that was clear in the previous example. I'm bringing that sign down. This to the third power is -8. That's what I'm writing in the parentheses. The same thing here. -1 to the third power is equal to -1. I'm just bringing this down, multiplying these two things. That's going to give me a -3. And a negative times a negative right here, that's equal to a positive. So +1 minus 3 equals -2. So my y2 value, that equals to -2. There, I have all the information I need. I know that my x1 is -2, my y1 is +2. And I know that my x2 is -1 and my y2 is -2, I'm sorry. And now that I have that, so let me make this smaller. I don't need this to be this big. I can now figure out the rate of change by using the slope formula. y2 minus y1 over x2 minus x1. So -2, and let me color coordinate this for us, all right? So y2 is this number right there, minus y1, which is that number there. So -2 minus a +2 over, we're going to have x2 is -1, and we're subtracting the x1, which is -2. So -1 minus -2. -2 minus 2 is not 0. That's equal to -4. And -1 minus -2, two negatives again make it positive. So this is -1 plus 2, which is +1. So the answer is -4. So this is the rate of change of this function on the interval of 2 and -1. Let's see, let's do another example similar to this where we're given a function and we have to figure out the average rate of change. So for this example right there, we're going to do the same thing. We're going to figure out the average rate of change by using these values, okay? So the way we're going to figure out x1 is by replacing the x value with this x1 value, which is 1. So here this is 1 plus 1 over 1 plus 6. 1 plus 1 is 2, 1 plus 6 is 7, so my answer is 2 over 7. So when x is equal to 1, the y value is 2 over 7. Now to figure out the y2 value, I'm now going to evaluate the function h with my x2 value, which is 4. So this will be 4 plus 1 and 4 plus 6. So this is 5 over 10, which reduces to 1/2. So when x is equal to 4, the y value is 1/2. So this is my x1, my y1, my x2, and my y2. So to figure out the average rate of change, our arc, we use again our slope formula, y2 minus y1 over x2 minus x1. So 1/2 minus 2 over 7 over 4 minus 1. I know the denominator is going to be 3. And 1/2 minus 2/7, that's equal to a total of 3 over 14. And when I divide 3 over 14, this fraction 3 over 14 is being divided by 3. That's going to end up equaling to 1 over 14. Let me actually explain and review how to divide a fraction by a whole number. So what we're doing here is that we have this number 3 over 14, and I want to divide it by the number 3. To do this type of operation without a calculator, 3 over 14, let me move over here, and to divide it by 3, remember that dividing is the same thing as multiplying by the reciprocal. So keep, change, flip. So I'm going to keep the 3 over 14 the same. I'm going to change the operation from division to multiplication, and that's going to flip the fraction of 3 over 1 to 1 over 3. So this ends up again cross reducing, and I could reduce these values right here. 3 divided by 3, because this would be 3 over 3 times 14. These 3's can reduce each other out, and I'm left with 1 over 14. So there's your answer. That is your average rate of change. Now we can also figure out the average rate of change by using a table. In this particular table, the table above lists the life expectancy of U.S. female born in a given year. So let's figure out the average rate of change in the life expectancy of U.S. females born from 1950 to 2000. And then let's find the average rate of change from 1950 to 2000. So here we'll start first with this one right here, from 1850 to 2000. Those are going to be my x1 and my x2. x1 and x2. The advantage of having a table is at x1, again this is my x1, it's already given me my y1. So I know that at 1850, the y coordinate is going to be 46.10. And in 2000, which is going to be my second x, 2000, the y value is 81.83. So here we're going to calculate again the average rate of change by y2 minus y1 over x2 minus x1. So this is my x1, my y1, x2, y2. So 81.83 minus 4610 is divided by 2000 minus 1850. And well, here I'm obviously going to use the calculator. I'm not going to go through the work on how to type into the calculator, but I'm going to get an answer of 0.2382. So this is my average rate of change. They want us to use again the measurement. Well, our measurement is going to be our age per year. So from 1850 to 2000, the life expectancy is increasing by 0.23 years. Well, they're becoming 0.23 years older per year. Okay, so the age in years over years. Which means that in every year that passes, they're living 0.23 years longer than they did the previous year. So in 1851, I would add this amount, and that's the average life expectancy that a woman born in 1851 would live. So she would live up to 1896.33 of the year. So we could do the math and figure out what month that would be. Okay, in 2 years they would grow again, she would grow that much more. In 3 years another, this amount will be added one more time, and then so on and so on. Now they also want us to figure out what is the average rate of change from 1950 to 2000, from so here to 2000. Well, the situation is going to be the same. Using again the table, we know that y1 would be 1950, x1 would be 1950, and y1 would be 7065. And that x2 would be again the year 2000, and the y2 value is 8183. So to figure out the average rate of change, we use our slope formula. So 8183 minus 70.65 over 2000 minus 1950. And again, using the calculator, we end up with 0.2236 age in years per year. And just like the previous rate of change, what this means that every year that passes, the women in this country, in the United States, females born in those years from 1950 this on, from not from the beginning, but from 1950 point, are only living 0.22 years longer than a person born the previous year. So if someone's born in 1950, this is how much they're expected to live. Someone born in 1951, well, that person would be expected to live 0.22 years longer than this person right there. In 10 years, in 1960, they could expect again to live 22 years longer than that, and so on, okay? Well, I'm sorry, 2 years longer. In 10 years, that would be 2 years. 2.28. That would move the decimal over, so that'll be 2 years longer, okay? Now, why it's so important, again, be able to look at the rate of change? Well, because in this situation, we can see that since the rate of change is not consistent in two different intervals, then we know that this correlation of the age in years that a woman lives in that's born in the United States is not a straight line. So notice again that it's a lot higher when we look from 1850 to 2000 than from 1950 to 2000. And we can start then in making hypotheses. Why is that? Why is that if we look from 1850 to 2000, the rate of change is higher than from 1950 to 2000? Well, it possibly could be again that because during this time, again, look how low that average age expectancy was. People were only expected to live to 46 years old in 1850. Well, what has happened from 1850 to 1950? Well, again, the advancement of medicine. So people are not again going to live obviously forever. So we're again, because the advancement of medicine, we're getting again to a higher expectation, but again, well, not too high, because again, we have an expiration date, obviously, and that starts to slow down. And how much more can someone again increase? Just like with natural resources. Yeah, when we first started digging again fossil fuels, we were just plummeting away, okay? But eventually, again, these things again are gonna eventually run out. So the amount that's produced is slowing down as a result every single year, because again, there's not that much reserves left over. And again, with any other situation, okay? So as a result of that, we see that this number, oops, didn't mean to erase that. This number right here and this number are not the same. So that tells us two things. One, it's not a straight line. And two, since this number is bigger than this number, that is starting to slow down. People are living longer, but the rate in which they're increasing their age is not going to be as bigger as it was back in the very beginning, when they were barely making advancements to how much longer people can live. Okay, so there you have it. So again, the key thing that I want you to get from this lesson is again knowing how to calculate this average rate of change, whether they give you a table, whether they give you a function, or they give you a graph. It all boils down again to using this formula right here. And the intervals we're given are x1 and y1. So we have to use, whether given again the graph, the function rule, or the table, figure out what the y values are at those specific x values that are given to us. Well, again, I appreciate you watching, and I hope you have a great day. and goodbye.